Hey there! In this video, I'll share with you an effective method for explaining the trends in the periodic table in elements going from left to right across a horizontal row called period. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. So the term period describes the horizontal rows in the periodic table. The first period at the top of the table has just two gaseous elements, hydrogen and helium. The second row or period starts with the metal lithium and ends with the noble gas neon. The third period, which is our focus for today, begins with the metal sodium and ends with the noble gas argon. However, the chemistry of argon is outside of our scope for today, but we will mention some of its properties as we discuss various concepts such as electron configuration. Let's start by looking at the atomic number of the elements in period 3. So going across from left to right, we see that we have an increase in atomic number. And that's how the periodic table is arranged. The periodic table is arranged in order of increasing atomic number. Sodium has 11 protons. That is because the atomic number is the number of protons in the nucleus of an atom. An atom is also neutral. It has no overall charge, which means that if the protons are positively charged, then each of these atoms will have the same amount of electrons which are negatively charged. So sodium has 11 protons as well as 11 electrons. The same is true for all of these elements. For example, phosphorus has 15 protons and 15 electrons. But how are these electrons arranged around the nucleus as they orbit the nucleus? And for that we need a very simple rule, which is the first shell can hold a maximum of 2 electrons and the second and third shells can hold 8. Therefore, the electron configuration of sodium is 2, 8, 1. That's 11. And that for magnesium will be 2, 8, 2. What we are already seeing is a trend that all of these elements in period 3, the same period, have the same number of shells. That is 3. And as we go across the period from left to right of the periodic table, in the same period, we are adding 1 electron to the valence shell, valence meaning the outermost shell, the last shell, to the atoms. 2, 8, 6 for sulfur, and chlorine 2, 8, 7. So we're adding 1 proton to the nucleus and 1 electron to the valence or outer shell. And that has a lot of information for us to unpack. Here's another trend that I'm sure you will have picked up on already, that there is a correspondence between the group number and the number of valence electrons. They are the same, right? So magnesium is in group 2 because it has 2 valence electrons. So here we need to mention something about the electron configuration of helium, neon, and argon, which would be placed in the last group on the right of the periodic table, which we don't have in our table here. And that is, helium has 2 electrons, its atomic number is 2. And it has only one shell, and that one shell has the maximum amount of electrons it can hold, which is 2. So it has a full outer shell. Neon has 10 electrons, 2 on the first shell and 8 on its second shell. It also has a full outer shell, and that means, like helium, it is unreactive. You see, atoms will react to gain a stable electron configuration, which they obtain when they have a full outer shell. So, sodium does not have a full outer shell, so it will need to participate in chemical bonding to obtain that noble gas configuration. Remember that the elements in group 0, the last group on the right, are called noble gases or inert gases. They are unreactive because of their full outer shell. So, sodium having 11 electrons, 1 valence electron, has to make a decision. It either needs to lose this 1 electron, so its second shell becomes its new full outer shell, or gain 7 electrons, so its third shell becomes full. Sodium would rather, in terms of energy, lose 1 electron than gain 7. So it will lose 1 electron, and its new electron configuration will be 2, 8. Similarly, magnesium would rather lose 2 electrons, so its electron configuration will also be 2, 8. Aluminum will lose 3 electrons, and its new electron configuration will be 2, 8. Remember that the electron configuration of neon, the closest noble gas to these 3 elements, is also 2, 8. So another way to look at it is that atoms will participate in chemical bonding by losing or gaining electrons, and we're seeing here that the metals are losing electrons to obtain an electron configuration that is closest to its noble gas. So there's another trend that we need to identify, and that is the electrons lost for metals also corresponds to the group number. So sodium in group 1 will lose 1 electron, thereby obtaining a charge of +1. How do we know this? Because sodium has 11 protons which are positively charged, and it lost 1 electron, which means it has 10 electrons. So with 10 electrons which are negatively charged and 11 protons which are positively charged, it has an overall charge of +1. Magnesium will form ions with a +2 charge, right? Because it's no longer an atom, it's charged. It's now referred to as an ion. In fact, it is referred to as a cation, which are positively charged ions. Silicon will neither lose or gain electrons, rather it will share electron pairs in covalent bonds when it is trying to obtain a stable electronic configuration or a full outer shell. For phosphorus, sulfur, and chlorine, they will gain electrons in the order of 3, 2, and 1 because they will find it easier in terms of energy to gain electrons in the order of 3, 2, and 1 than to lose 5, 6, and 7 electrons respectively. So in gaining 3 electrons. Phosphorus obtains a charge of -3. And its ionic configuration as an ion will be 2, 8, 8, which is the same electron configuration of its closest noble gas, argon. Sulfur will gain 2 electrons. Chlorine will gain a single electron. The charge on sulfur anion will be 2-. For the chloride anion, it will be -1. Two, 8, 8. Before we look at the relationship between gaining and losing electrons and ease of ionization, let's talk about the state at room temperature and whether these elements are metals or non-metals. At room temperature, all of these elements are solid except chlorine. So solid. Now we would expect that since silicon, phosphorus, and sulfur are non-metals, that they would be other than solid at room temperature, but that's not the case. At room temperature, these elements are in the solid state. Now, metals will lose electrons to become stable, and so that is one characteristic of metals. There are many other characteristics of metals. All of these would be non-metals. With the exception of silicon, which is a metalloid. Metalloids are substances that have properties of both metals and non-metals. And finally, let's discuss these 2 points of comparison for the elements in period 3. Going from left to right, we have an increase in effective nuclear charge, meaning because there is one more proton being added to the nucleus of the atoms, then we have a greater attractive pull of that nucleus for the valence electrons, which are on the same shell. So we are filling the same shell going across from left to right, but we're also increasing the attractive power of the nucleus for the valence electrons, and so atomic radius decreases because there's an increase in effective nuclear charge. However, the opposite is true for metals in terms of how easy it is for the atoms to become ions. If the nucleus can hold on to the electrons with greater attractive power, then it becomes harder as we go from left to right for the valence electron to be lost. So, ease of ionization increases from right to left for the metals. However, for the non-metals, ease of ionization increases from left to right because effective nuclear charge is increasing the attractive pull of the nucleus for incoming electrons or for the electrons on the valence shell, that's increasing, which results in less energy required to take on incoming electrons. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to refer to concepts such as effective nuclear charge and adding electrons to the same valence shell to explain trends in periods from left to right of the periodic table, such as atomic radius, metallic character, ease of ionization, and the type of ion formed. Good luck on your exams, and I'll see you next time.